see. Yeah. Let me move around the slide. There are a few technologies available with in Autodesk in terms of generative design. Okay, so in this chart comparison, right, you can see what are the differences. It's beyond just the definition. You know, it's because of making it works, right? You really need to have a lot of technology behind the scenes. And Fusion 360 is with the generative design that I've shown you early on. It's actually just the beginning, right? In Autodesk, we have a few more other technology for generative design. When you have the shape, right, come up, you know, I mean, you can read on your own, you know, it's talking about like the differences, right? We have both of this technology. Now, topology optimization is already available in Inventor. It's also available with Fusion 360, yeah. But for generative design, it's only available with Fusion 360. And the workflow, I already explained it to you. And there's another, let me just give you the official one. This is the official one with a lot of information given to you, right? So this is the workflow, right, of additive and generative workflow, right? So as I mentioned to you, Fusion 360 generative design, the topic is only the entry level. So don't think about it as like, wow, so difficult and so hard, because it's AI, and you know, in an environment that are so integrated and so friendly to you, and you can have easily collaboration with any friends. If you do not know how to use this function and that function, you just invite them, and they can easily just get into your project and your model, and then tell you, oh yeah, you can use this approach. But this is just the beginning, you know, for generative design. We have these tools already merged together right now, and then we have another one which is NetFab, because the NetFab will involve the lattices, the lattice structures inside the model, right? And you're talking about how you're going to optimize it, and at the same time enabling it to, at the time when you do printing, you want to eliminate unnecessary warpage issue, and so due to heat, right, it will warp, right? So this is the complete workflow. Towards the end, you need to export it into CAD. And then maybe in the CAD itself, like what I showed you earlier on, you need to refine it by dragging it and changing the shape and all this, right? So information to share with you is in this slide itself. I'm just going through some URL links. So all this is already been explained in a different manner, right? Talking about like the concept of generative design, okay? So multiple choices, right? You know, but you want eventually towards the end for time to market in the futures of producing stuff. This is the way, right? And so the overall concept of generative design, for why I'm here, I think my intentions here is not telling you about, you know, the futures and the business aspect of it, you know, like all this explanation to justify. It's more on the workflow and in the detail, what you call the workshop methods, right? Therefore, these are already explained to you when you're doing the design explorations, right? And again, like I said, this is the entry level using the Fusion 360. I did explain to you the color full result, which is talking about the stress, right? And of course, I can switch back into the model and explain it again. What is more important is to give you more education information here, yeah? So what are the education information here? I'm just going to jump into the link. There are a few, okay? So of course, the foundation is begin with Fusion 360, and it's already mentioned how to do it. Number one, in Singapore Poly, you really have the access of Fusion 360. It's not free trial, right? You can learn the basic and foundation. Then you want to go into generative design. It's really expensive, okay, but you can still do the trial using the cloud credits. This is one site. Now this is another site. This site is you can see the URL, right? And I mean, you can do a search if otherwise you maybe want to take pictures of this, right? So this is very education, a lot of video and explanations of step by step of giving you the basic understanding of generative design. This is completely new things in our initiative for this year to promote a lot about, like, you don't want to know more about it, right? So this is the first URL link you will need to get into it, right? And of course, you have the software, right, first, right? And this is the same, you know, that link and this link is the same, right? Okay, so, and as mentioned to you, again, I will just show you one more time with the software. And the software itself with this, this is actually the Fusion 360 again. Towards the end, right, I mentioned to you, these are of course, they are tutorial, they are step-by-step guiding you. But if you get into the samples here, a lot of all this, like example, ready to generate. The moment you open it, you just do generate. You know, you can study how to get into that. You can study what do you mean by obstacle, what do you mean by preserved geometry, you know, all those things that you want to know. Okay, so I think I'd like to share with you a story of, I mean, not so related, but it's actually a workflow of how this is a part which is very common. You can see the word grab cat is not us, is you know, you can get a lot of geometry and a lot of model from the internet, right? Download it for free, right? And this has been around for a few years, and then we use this model. Actually, it's a quite high-tech General Electric's jet engine brackets, right? That you want to solve the problem of using generative design. So it's like a benchmark model, you know. So there is a video to explain to you step by step, okay? And I'm not going to go through that in details. I'll just fast forward to show you that the modeling, right? And when you have the model, right, all these cylindrical shape, you are selecting them as a preserved geometry. Now, think about it right now in the integrated Fusion 360 environment, because you can model them. You can drag and change the shape like what it did, right? So once you've done the modeling, you switch into the generative design function, you will be selecting, okay, this shape is going to be my preserved geometry. So, and preserved geometry, you come into one color like green color, preserved, then when you generated the model will come with this green color geometry. It will not change, right? Then you're going to further and make the red color is actually the obstacle, meaning to say it's not going to beyond this boundary, right? So it's when you generate the model, it can get haywire, right? You know, you must go some certain constraints to tell them that these are my obstacle, right? So based on this, and then of course you giving some input, and this is where I was saying to you, you know, you need the cloud credit point, and so when you solve it, then it's actually giving you the choices in exploration. Towards the end, of course, this is in the whole integrated environment. Again, once you solve it, right, you have the choices, right? Some of the choices may be rubbish, you know, and you need to, you know, discuss it because based on the geometry shape preview to you, you know, it's like, it's rubbish, it's boxy shape, it's not optimized, right? So once you have made the decisions already out of so many choices, right? And again, like I say, it's AI generated, then you can say, I want to export this into the CAD model. So once you export it into the CAD model, you will further doing simulation and you further optimize it again. Like, you know, I did show it to you because it's came with the history, right? So you can further reuse it and say, I want to use a little bit more human interventions to improve this further, right? So the important part of this slide is explaining to you the workflow, the last part of it, right? And using the case study of the General Electric's brackets, okay? We actually have many success stories. Now, if I give you a very quick preview, all right? Let me go back to the other slide of. Now, up to now, do you have any questions that you want to ask me before I move forwards with some overview again about the success story with the generative design and how people have been using it successfully with our customer? There are many examples of our customers. That's what I'm trying to load up those examples and show it to you. Do you have any questions? With regards to, the topics for today is generative design. And generative design actually using the entry level of our software called Fusion 360, which again, you already have it. You know? So moving one step further is the things that we are introducing you here now, right? So, yes, you have a question? Yes.
They say it's not available on the educational license, the generative part.
You can do trial. Yeah, when you do trial, you have 30 days. And that's why I've asked my colleagues to explain to you first on that part. You know, because once I explain and say, make you excited about generative design and you want to do it and say, oh no, I cannot do it, you know. So, you can do trial.
Sure. Yeah, I think we can start with trial. Which school are you from? I see that you were traveling with Vision as well.
Singapore.
That's me.
But under Triple E.
Under Triple E, right? Yeah. So I think with the Triple E side, you also have basically a lot of IoT linked to design as well, right? So
So more care.
yeah. So we are in the process of speaking with your different faculty because, like we mentioned, that generative design is it's an AI based, so it's cloud consumption. So it's basically there's basically a cost, but we are working with very specific institutions to have this AI design-based function or tool into some of the institutions. Okay, I just have a go at it, just have a try at it. Once you use Fusion 360, generative design is going to be a very complementary part to your design because you're letting the AI. Once what has done a great presentation, you're basically with the design, you're fixing constraints. After fixing constraints, you are then using the AI function to generate it. So that bracket, for example, can be a weight reduction of about, I believe, it was about 43%. So from a lightweightedness and an optimization of the component, it's about 43%. So it's a really big part.
What I have, the rest are just some example of our customer who are already using Fusion 360 to do the job. It's not just restricted to the example that you see from the what do you call the samples, right? You know, so this is a real customer story.
Claudius Peters
Something
is a
very
premier
big.
manufacturer of cement plant equipment. This year, their digital team began experimenting with generative design. The clinker cooler was the first application. Saving material is an important cost factor in this heavy cast part. Using Fusion 360, the team applied goals and constraints and began to explore options. They took the result, reverse engineered it into Autodesk Inventor, and created a final part that reduced materials and improved the structural integrity of the cooler.
So again, you know, this is a
Claudius Peters is a
example of our customer. There are others like what we can see from these pictures here, right? And I do have the model of this one. This is like the brake system, right? And you have the generative design model here to hold the pedals, yeah, to hold the brake pedal when you know in the car, a brake system or accelerator, right? And this is another one. So the lightning motorcycles, right? So they want to optimize this swing arm, you know, the swing arm here, the silver color, right? So and this is the original design, of course, right? So when you take this out and say you put in all those reserve geometry, obstacle, and all those things, it's the same process. You can see the UI right now, it is still the old UI before we merge them together inside the Fusion 360. So we also like, you know, evolving, you know, to be better and better, you know. So the old UI now is gone already, and you know, we just all inside Fusion 360, right? And so so based on this again, it's a real testimony of the motorcycle's swing arm component, and eventually, of course, the shape that they design come up in this manner. And yet, you still need to do some machining. You see, that's the beauty of it when it is inside the one environment where you can actually make decisions to say, I want to do subtractive manufacturing, because sometimes you know having a metal printing, especially something very big, right? It's very challenging, honestly, because the price factor for owning a metal printing machine for something big scale for architectural purpose, right, is very costly, right? So And so you may need to use WISE methods or some nowadays slowly going to come up with more effective, more cost-effective kind of 3D printing methods, right? Kind of printers, but still, you know, it's not going to be perfect, and therefore the subtractive using the machining capability here will assist you to make it a much more perfect model, right? So this is a real example, right? And of course, I do have many more examples of our customer, and I think, you know, I'll leave it to you to see if you have any more questions. Otherwise, I will call this an end for my presentations. This is another one. The customer of us are the back mono, all right? It's a British sport car. And then this the pedals, the automotive pedal, they wanted to use a generative design to design the brackets, the underneath bracket there, right? So they make it much more lighter, you know, because performance car, right, sport car, right? So it's the only constraints to you is your imagination. Okay, if you can imagine the workflow, how does it actually work? You know, that's the purpose of I'm doing this workshop. Then you can use it and apply it to say, I want to use 80% of the AI to do the calculation for me to come up with some shape, right? Now, at this step for you in your learning step, right? You are also like generative design. Your brain is like why? Because you are in exploring, right? So once you know and you get the gist of it out of it, right? Now you say, oh, this is the way. This is the real evolution. That's the reason why we are advocating so much the terminology, you know, that of generative design and the futures of making. Right? Any more questions for me? Yeah. Go ahead.